Hello everyone, my name is Piotr Stawirej, and today I would like to continue my talk from the previous conference season about the testing the untestable patterns, use cases and practices. Currently I'm working at Revolut, as you can see in the business card departments, and what problem I'm trying to solve with this presentation. By the way, anyone was seeing the first part here? Okay, there are a couple of people, thank you. So what problem am I trying to solve? First of all, I would like to continue to answer to the common questions about the testing practices. I would like to continue to explain the unobvious testing approaches, and I hope after this presentation we will reduce the knowledge gap in the area of the testing. Why is it important to solve in the first place? Of course, from the business perspective, it is important to save our time and money. I have my personal mission to make our life and your life a bit easier during your daily activities. And I hope we are going to learn something which allows us to reduce probability of creating a legacy systems. And I hope you will be prepared for what you may encounter in your daily work. What other solutions might there be? During this talk, I will also, for some cases, try to show you what there are other alternatives or what are the popular cases available in the world. And it's always too good to have like additional alternatives and extend our toolbox. Why propose solution? Why we should even bother to sit here? First of all, they were tested in the battlefield. They were not tested once, but they were tested by me, by people I trained, or people I cooperate with on the simple projects, but also on the very complex one, on the enterprise level project. And I've encouraged you, I hope you will try some of those approaches, and if they work, please give a feedback to me. If they will not work for you, even more give a feedback to me about it. Let's jump into the first use case. Correctness of the value objects. Value objects are the cure. For what disease? Primitive obsessions, when we are using long integer strings directly in the code and embed those business invariants directly in these primitives. Value object is an object that represents a simple entity whose equality is not based on identity. For example, I worked many years in the map-making company, so I had an opportunity to look into OpenStreetMaps, for example, and one attribute of the data present there is tag. Probably we are all familiar with this construct in the new Java, record tag string, yeah? Pretty clear, pretty obvious. And those, this value object, this attribute, in fact, tag, in the terms of the OpenStreetMap, it has some kind of the rules. This is not like we can put all the text there. For example, it has to have the minimal amount, the minimal size 1 character, maximum size 255 characters. So did we ever consider that value objects, in fact, keeps those low-level business invariants? For example, we have an ID. What are the correct range for those ID? How do we calculate correct value for these edge cases? What are the text constraints? For the OpenStreetMap, for this tag, it was from 1 to 255, the size. However, in our system, does it make sense to have the value object, the tag, which consists of only white spaces, or starts with the white spaces or ends with the white spaces? Maybe we could trim it. So this is like low-level business invariants embedded in those value objects. And maybe it will be a good idea to test them, and how we can easily ensure correctness of this value object. And do not write all those boring edge cases. And here comes the property-based testing. Anyone was using it in some projects? Okay, I see like 3-4 people. So property-based testing tries to combine the intuitiveness of microtest with the effectiveness of randomized generated test data, originally driven by the common hype about functional programming. PBT has meanwhile been recognized as an important ingredient of any up-to-date testing approach. Okay, it's much simpler than it sounds. We just want to have some kind of the tool, some kind of the library, which will generate, for example, 1,000 random samples with the edge cases, if it's possible, and run this 1000 tests for us and check if our system under test behaves correctly. And it's extremely useful, these techniques, to test these value objects or start with value objects. In some cases, we can have the corner cases for free. If we are working with the test-driven development approach, again, we will write the failing test, but we will write the test once, and those 1000 tests will be automatically generated for us. So this is like blazing fast TDD cycle. What I personally like the most about the property-based testings, it catches the errors not manifested by mutation testing. So if you have already unit test, mutation testing for some kind of the crucial part of your application, maybe it is worth to consider add another testing layer, or even get rid of mutation testing, or even if you don't have, maybe not get rid, but if you don't have mutation testing, instead of mutation testing, apply property-based testing. For Java, we have a couple of the libraries. I've tried some of them, and I think the best one is JQuick. First of all, it's based on the JUnit 5, so it will see that tests are very similar to the JUnit ones. It has extensive documentation, which is important, and for the third part, it has nice extension. For example, for generating test data, for example, for the email addresses, URLs, or for the time and date. Let's jump into example. How does this test look like? So we have like create node with valid ID for all long range starting inclusive 1 to long max value. I would like to just create a node with this generated ID and then just compare it. Instead of the add test, we have add property test, and the test looks like the test written in the JUnit, right? Very similar. So there is not like, whoa, totally new approach. Of course, we would like to test the all negative scenarios. So report error from invalid ID for all long range starting from min value to the 0 inclusive. I would like to catch throwable for creating no node for such ID, and then I will get this illegal argument exception. Node ID must be greater than 0, but was something else. Yeah, pretty easy, nothing fancy. I would like to, at the moment, stop and talk about the defaults, because by default, JQuick library will generate 1000 tests, 1000 tries. And what I've encountered during my endeavors is like, in 99% of the cases, it is already too much. You can set the defaults for the tries like 100 or even 50. However, when it comes to the testing the text data, I encourage you to use the value like 10,000. It will allow you to spot errors much faster. They will manifest on your machine or on the continuous integration server. For the text data, start from the 10,000. The second thing I would like to stress about is using this edge cases mode first. By default, this library will generate 1000 random samples, but edge cases may be there, but may not be there. And I think it's very valuable to have all those edge cases in the first place to be generated. So you can put all those this first line in some kind of the IntelliJ or your IDE template, file template, so it will be automatically generated when you create these files. Very useful annotation is reporting generated. It will show you, it will show you in the test run all the cases you've generated if you would like to examine them. However, finally, when you will leave those tests as production ones, delete this annotation because it will slow down significantly speed of your tests. This is the report for the summary of the report for the test we've already seen. We see like tries were 100, checks were 100, generation randomize, this is important. Edge cases total 4, edge cases tried 4. If we will not put this annotation, generate the edge cases first, it could be like 3, 2, or 0. And we have like the seed. If in case of the failing, don't worry, you can retry exactly the same test with this exactly same data, so it's easy to debug. Nothing shocking, nothing interesting at the moment. However, this is more interesting. This is the report from production code. So this was like production value objects I've created. It was tried 50 times. However, this is the important part. Edge cases detected 8 by this library. Edge cases tried 8, and I came up with 7. So I've missed 1. And this library already helped me to find this missing edge case. So this it's starting to be more interesting. If you think that at the moment it's all rudimentary and we don't have to even bother to testing such things, please answer me to this test. Will this test pass or fail? Absolute value of all numbers is positive. This is the Java code. And we have for all integers, so from min value to max value, we are going math absolute from this integer, and assert true value is greater or equal 0. This test will pass or fail. Who thinks it will pass? Who thinks it will fail? It will fail. What documentation states and what will be the output if we are going to call the absolute for the mean value, integer mean value? It will be negative, and it's in the Java doc for this math ABS function. Okay, next example of this. Compare for all integers in range starting from 0. We are generating integers starting from 0, and we have like boxed versions of integer a and b. We are assigning this value generated here, and by reference we are trying to assert a equals b. This test will fail or pass. Who think it will pass? This test will fail. However, it will not fail for the all integers, depending on the architecture, but basically for the first 128 integers, they are cached. So this test will, comparing by the reference, this test will pass for the first 128 integers, basically, but for other it will fail. This one is easy one. So we are concatenating some strings. So length of the concatenated string is greater than length of each. And we are generating some random string 1, random string 2. We are adding them, and then concatenated length is greater than string 1 length, or concatenated length is greater than string 2 length. It will fail or pass. Who think it will pass? No one. Yeah. It will fail. Why? Because we have characters with 0 length. Yes? And one thing from the production code, I've tested the value objects on, for the text, and I've used Apache Common Lang free library, pretty common library, I think, when it comes to testing the preconditions. And when I've created very similar test for let's generate some random text, I've encountered a bug in this library, in those guardian clauses, like checking if text is not blank or not null, and so on. One character caused an exception in this library. It's already fixed. It was like 2 years ago. So it is pretty good to generate some kind of the weird data and see if on production our code is bulletproof and will work. Of course, it is not limited for value objects. I don't really recall, like 3-4 people already tried the property-based testing here, so most of us haven't tried yet. So let's start with something simple. And I think for the property-based testing, it is extremely easy to start with the value objects. And then when you and we will get familiar with the tool, with the approach, it's extremely easy then to move forward and apply it for some more complicated stuff, like for some kind of the discount algorithm or something like this. So it is not limited for the value objects. Testing value objects is the first step. This is nice, easy entrance to this technique, and then we can go and test it for the more complicated stuff. I think I've only do a pros for this, so only advantages, but there is one disadvantage for me. When it comes to the generating very complex random data, complex structures, of course the JQuick provides some kind of the providers which we can create. However, I switched to the parameterized test in the JUnit. I think they solve it a bit better, for example, add method source, and I can much easier provide random or generate those data for more complex structures. For the simple ones, I go with the jQuery. No-brainer. But for the more complicated stuff, it seems, for me, personally, a bit easier. Okay, this is not the presentation about the property-based testing. This is just an introduction to the technique, which is extremely useful in some cases. Let's jump to another use case, internal cache. We would like to implement the functionality which we will implement the cache for the sake of the performance and so on. And constraint is we do not want to expose this cache in our API. So in fact, we have some kind of no visible action result, yeah? Because on the test environment, when we have limited amount of data, it's pretty fast. If we will run those code with cache or without cache, and it's already pretty decent implementation, we will not spot the difference. So how we can test this in the first place? So let's go and create our library. We have private final cache field. We have private constructor, and we are going to inject our cache. We have a new instance factory method. I've used, for the sake of this example, caffeine library, and we are creating like new builder, maximum size 100 for the cache, expire after 10 minutes, and build. Pretty easy. I think everyone gets it, yeah? What's happening here? Okay. And then we are returning this new library with this cache. And we have some method which uses this cache and do some functionality. So how we can test it? One approach, one alternative is drop the access modifier and make it package private. If we have test in the same package, it will be pretty straightforward. We will just create a cache in our test, so caffeine, new build, even the version which records the statistics. Then we are going to create our library with this cache we've just created line above, do something, and then cache statistics hit count equals 1. Yeah, we understand what's happening here. Pretty easy. However, what with the situation when we have different package? And there is one powerful pattern which is called extend and overload. It is from the book Working with the Legacy Systems. And instead of dropping the access modifier, let's go and put the protected one here. Not great, not terrible, but a bit better. And then in our test, we can create a fixture test library, which is going to extend our library. And here we can overload the constructor and in tests inject our test cache indirectly. This is how the test will look like. So we are again creating our cache, but instead of creating new instance of our library, we are going to create the instance of this test library, our fixture. And this will allow us indirectly test our functionality and check if cache was used, but cache is not exposed in public API to the external customers. Let's push this pattern even further. In use case 3, what if we have private immutable field? And this field, we don't want to change it in the first place. It may contain some kind of the production critical information like connection strings to the production database. We can see it's private final to defaults. To stress that it's immutable, we even use this immutable map, and we don't want to change it. And we don't want to do those hacks or patterns from the previous slides. We have again the private immutable field constructor. We have some kind of the public method in our API which uses this defaults field. So how we can approach this case and make it open for the testing? First of all, again, let's apply the trick we already know. So let's, for our private constructor, let's make it accessible a bit. So let's make a protected access modifier. And then, additionally, we need to create auxiliary method protected, which returns the map key value, defaults, which returns this defaults field, class field. Yeah, you are with me so far? Okay. The pace is good? Yeah, okay. And then, small refactor, and instead of using in our getValue method, instead of using directly the field, let's use this auxiliary method. And what will happen? Again, we can create a fixture in our test immutable field, which extend immutable field class, and then we can override our defaults method. And here in this map, we are able easily to put our test values. Is it clear what happened here? And we didn't touch the private field at all. But we did some kind of a safe refactoring, and then we can easily switch this immutable data in our tests. And this is how the test will look like. So test immutable field, new test immutable field here, and regular test stuff later. Okay, use case number 4, fault tolerance and resilience. We are starting new sprint, we are starting new iteration, and we have a business requirement. Let's create some kind of the integration with the external system. We need to develop some kind of the library which reads and writes from the external system. This blue part is ours. We are going to develop this. This is external system. And when it comes to connection and integration with the external systems, what are the problems? The network, for example. Yes?
Network price.
Yes, exactly. Network price. For example, the external system can be down sometimes, and we don't know what to do with that. Yeah, so this is like those challenges we have to do. And how we can approach designing and developing such such library to be open for testing and test even those at the first glance hard to test cases. So first of all, we would like to separate the business rules, the functionality itself, from the handling failures policy. This will allow us in the simple unit test, separately test the business logic and handling all this fault tolerance and resiliency. And what we can do to achieve that, we can use good known old decorator pattern. This library will consist of functionality to just simple functionality to trying to retrieve some information from this external service. But here we are going to create a decorator, and this decorator, it will encapsulate only the fault tolerance and resiliency policy and handling it. Let's see at the implementation. We have our interface library with some example long get user count. We are going to implement in the first place the basic functionality, which is my library, implements this library interface, and we have get user counts, override this method, use some REST call or whatever you want to just connect to this external system and fetch the data. Yeah? Pretty straightforward, I think, at this place. And then, how the decorator would look like. So we have the private final library field. This is our original library. And here we have private final retry policy. For our case, it will be retry policy builder handle could not fetch users count class with delay with duration of 1 second, max retries. This is important for the sake of the next slide. Max retries free and build. Yeah, pretty straightforward, I think. Nothing complex. And then we have constructor when we are injecting our library. And this is the interesting part, how the method get users count will look like. I've used, for example, the failsafe library. So failsafe with this retry policy we already defined. Get, and here we are calling the original method of this base library get users count. Is it clear what's happening here? Good. And then, if you watch the previous presentation, you know that I'm not a big fan, gently speaking, of the mocking tools, and I've encouraged you to write your fakes, stubs, and mocks from scratch in Java. Yeah, it may be shocking for some of the people. And let's create a fixture for the sake of our example, class failing library, which will implement our interface library. And let's override this get user counts, and now we can simulate all this strange situation which may occur during the connection with the external system. For example, if attempts is less than failed attempts, let's increase attempts, and throw could not fetch count because internal server error. Otherwise, just return some fake regular data. Is it clear what's happening here? More or less. And let's look at the test. Retry when failing fetch users count. And here we are creating failing library. So I expect this library will fail twice. Retry library, this is our decorator. We are injecting our failing library here. It will fail twice. We remember that failing policy was to retry 3 times. So we have like retry library get user counts. For this case, there will be a success, yeah? Users count is 1000. Everything was as expected, and we have extremely simple unit test. Let's check fail fetching user count when retry count exceeded. Let's create our failing library with the value 4. So already fail 4 times, inject it to our retry library, our decorator, and then we are expect that there will be some kind of the exception, like could not fetch users count, server is down, something like this. Of course, we are missing what? The edge case, so the failing library for the value 3. But you get the point, I hope. And it's extremely easy. Now we were just simulating consecutive failures. But for example, for the intermittent failures, it's also extremely easy now to simulate. And we don't have to use all those fancy third-party applications which will degenerate, for example, the network for our test. Did you use that? I used this in the past, yeah. And we now, in the simple unit test, for example, we can simulate that, okay, I have 5 consecutive correct calls, I have 6 one will fail, again, I have like 10 correct one, again, something will fail. In the simple unit test, I can create simple unit test and simulate all the real life situation without this third-party libraries. Use case number 5, multi-threading and concurrency. Again, we will apply the same concept which we've already seen, and we will gonna to separate the functionality, the business rule, the business requirement from the concurrency, from the multi-threading, and we will gonna test it separately. And this idea is not only for the new code for the greenfield projects. It will it is extremely useful, for example, for the legacy code, when you have already some business logic entangled together with the multi-threading. So we will learn how we can approach this situation. Multi-threading and concurrency is pretty tough. Yes? There are people who think it's easy? No. So let's make, in the Java world, for example, our executor explicit in the API. So if anyone who is going to use our code, even internally, they will know, okay, we have to deal with the concurrency and multi-threading here. This is important stuff. So let's make it explicit in our API. Then, if we will make it explicit, it allows us to inject different concurrency policies. What's more important when we are starting writing test for the multi-threaded code, remember to synchronize the test thread with the background thread. We would like to avoid the situation when we are going to run our test and our multi-threaded code, the test will pass and is green, but the multi-threaded code in the background thread is still spinning up, yes? For the code which runs for the longer period of time, remember, for example, for the JUnit, you can use assert timeout preemptively, so not wait until something happens, because we may have situation when we end up with the endless loop, and we will wait like for 24 hours until someone will manually delete it. But assert timeout preemptively allows you to set like, okay, wait 5 minutes, if nothing happens, just fail the test. And it's worth to mention that we have to remember that in some cases, we need to synchronize mock, fakes, and spice operations. For example, if those spies gather additional information from these multiple threads, we would like to gather those informations correctly, so we can reason correctly about the outputs. Let's jump into example. I would like to implement some kind of the search. And in the first place, I would like to, as I mentioned, separate business rules from the multi-threading from the concurrency. How I can achieve it? We've already made our executor explicit in the API, right? So we are going to inject in this first test deterministic executor, and it's something like deterministic scheduler. I've already mentioned, and people who work with me knows that I don't use Mockito, PowerMock, or any kind of the mocking tools. However, there is one little gem. Unfortunately or fortunately, the word is not black and white. There's one little gem in pretty old library called JMock, which is deterministic scheduler. And if I'm going to run the search query, originally with the multi-threading, but injecting this deterministic scheduler, this will be the output. Let's examine. Search runable A is running, A is done. B is running, B is done. C is running, C is done. Do we see what happened here? It ran all our commands in sequence. If we have legacy system already with the multi-threading, and we would like to discover if we have a bug in the concurrency and multi-threading field, or if we have a bug within our business logic, let's inject in the first place this deterministic scheduler. It even allows you to run commands one by one. So now we can easily see, okay, we have a mistake either in the business rules or in the concurrency. And if we would like to test it for the concurrency only, in the previous test we've confirmed that our business rules are correct, everything is working. Now let's check if everything is working correctly when it comes to the multi-threading. So now we are going to inject real one executor, new fixed thread pool, and here in our search we are injecting the real one fixed thread pool. And we expect that there will be some expected result. Is it clear what happened here? We've just separated multi-threading and concurrency testing from the business rule testings. And it simplifies significantly, for example, for the searching and analyzing the bugs. Here we can see the output. So search runable C is running, B is running, A is running, C is done, A is done, B is done. So pretty scrambled. We can see that the real thread policy was executed here. Everything is clear so far? I hope, okay. Libraries. If you would like to test the multi-threaded code, anyone was testing the multi-threaded code? At least tried. Yeah, okay, a couple of the people. So you can use the Tempus Fugit, Threadweaver, multi-threaded TC libraries, or one I recommend is JC Stress, and highly recommend trying the last one, Threads Collider, because I wrote it. And this is the example. You don't have to use any fancy annotation, magic annotation, whatever. In this example, we are creating simple array list. So let's check the thread safe adding to list. We are creating new array list, pretty clear. And then in this Threads Collider, just add an action list, add some text for all available physical processor on your machine. And what this library does, it tries to synchronize the starting point of all the threads on your physical cores, and it does pretty well. When I've examined it, multiple threads were started exactly at the same nanosecond. It's extremely simple, but extremely powerful, and allows you to easily manifest if you have on production some kind of the errors and you would like to reproduce them in the tests. Okay, testing logging. And this is not like WTF, what's happening? Yeah, testing logging. Logging is a feature. Anyone was testing logging here? Okay, it's more popular than I thought. Okay, logging is a feature, and we can distinguish between support logging and diagnostic logging. Support logging is all those stuff, error info, it's part of the user interface. Not only we as a software developer is going to read this on the production, but also some kind of the operators, people who monitor our application. If something better will happen, they will also examine those logs. And they're used to monitor running system. And we have those diagnostic logging, which is debug trace for programmers, and it should be generally disabled on production. So if the testing is a feature, so it should be test-driven from the client perspective. If we will start from the test, what should be logged in the first place, then there is a high chance that we are going, in fact, think about what kind of the message and what kind of the informations we would like to have in this error message. And good message will contain those: failed operation, value causing error, expected values. And it will just help us avoid the situation, I don't know what to do with the exception, I will just log it and carry on. Yeah, we've seen this. Okay, retro, log, done. Error handling done correctly. Let's examine some examples. Report error on wrong filter. Here we're having some wrong values, and let's examine the error message. Then throwable is instance of could not apply filter, has message could not apply filter, and we have what was the wrong value here already. And then available filters, what are the correct values. So already, if we are creating the error messages in our systems, put the information what was the wrong value, but also put the information what was the correct value. Maybe people who analyze these logs will not call you and ask what happened, but from this message they will be able to respond to the customer already. But my message will change. And I've noticed in the multiple publications in the last years that there is like we try to discourage us from testing the message itself. And there is like, why? Because I have to update the test and my message will change. In fact, what I've seen from the past years, no, you don't. In fact, there will be two cases when you will update this test and this message. First one is we will have bug in logging message. Yes, it can happen. In this catch clause, we can have situation when we are concatenating multiple parameters and we just missed something, or we are trying to display some null value. And then it will be manifested in the production, but if we will write the test for it, we will catch it much earlier. And second case is improve message to contain valuable information. Yes, I had the situation like during the writing, I know what this error means, but after a month, I'm not sure. Did you encounter such situation that you don't know what your code is doing after some period of time? Yeah, we've all experienced this. So in that case, I'm improving the error message. But if it's a feature, it should be injected as a dependency, and this is like madness, yes? Anyone is angry already? In Java world, it is pretty popular to use this SLF4J, so we don't have this as an explicit dependency. We are using some kind of the magic to, so this loggers is injected. The good point is like it is convenient and it already supports the supporting logging and diagnostic logging. So we will not spend a lot of time on that. However, if we would like to test logging, popular libraries like this SLF4J already provide some functionality which allows us to do it easily. For example, we can extend the appender base for this SLF4J and create in this factory method new instance here, some kind of our test log appender, then get our logger. This logger will append our appender. So this is like the preparation code for creating our custom logging. And important part is overriding this append method here, and we can collect here to our field, to our array, all the events. This is the rudimentary, very basic approach, but here we can apply some filter. For example, I would like to gather only error level events. Yeah, pretty simple to check. And why we are going to do that? For example, I had a situation when we had a functionality to sending emails to external to the clients using external service, and we were after sending to this queue to this external system, we just logged that everything on our part worked or something failed. So we already were able to determine, examining the log, like if we messed up or the third party messed up. Yeah. So this is those kind of the messages is in fact the functionality on which we were looking at. And we can just, before each test, create a new appender, and after each, just stop it to restart it to the origin state. Okay, let's go with the comparing. Don't worry, I mentioned I work at the Revolut, but we don't use big decimal, so this is like not Revolut-related code. Someone may create a class for handling money and use the big decimal and currency. pretty straightforward, look clean, looks nice. Then we are going in our IDE, use the functionality to generate the equals and hash code, so they have to work, right? They already looked pretty legit. We have this object equals denomination, money denomination, and objects equals currency, money currency. Will it work? Why? Well, yes, because big decimal from text 1 is not equal big decimals to 1.0. When I'm running a trainings, it's like 50% of the groups always fail on this exercise. What we can do? We have a pretty neat library which is called equals verifier. In 99% of the case, we are going to use this rudimentary approach for class money class, just verify equals and hash code. And in our case, we will gonna receive something like assertion error, object does not equal a copy of itself, where big decimal, and so on and so on. Solution for this particular case will be do not use big decimal, implement equals to use compare to for big decimals field, normalize the big decimals fields during your class constructions. And also this library, when you are going to, on the official documentation, examine this error log, they will give you those hints what you can do. Moreover, what is more important here is remember that objects equality is part of our behavior. I've encountered situation in the past in our code when we explicitly would like to have comparison only by reference, not by this logic comparison. So this is, again, this is a feature, this is the functionality, and we should have some kind of the test for it. And last but not least, testing persistence. This is like topic for the totally whole separate presentation, but couple of the things. If we are going to test persistence, so what kind of the options we have? I recommend to use, to watch the first part of this presentation and what is going on with using in-memory fakes, in-memory repositories. This is basically when we would like to test business rules. However, if we would like to test the integrations, some teams, some companies maybe still have the local database or database on testing environment, not great, not terrible, but most popular is the test containers. I recommend to watch some, like for example, Piotr Stawirej talks about the test containers. He covered this pretty deep. But things I would like you to remember. When we are going to set up in test containers Kafka, RabbitMQ, or Postgres, Mongo, whatever, first of all, the advantage is like we are integrating with the real, something real, a real external system. So we can test functionality and we can test, for example, the Q API if it works. Second, remember to use exactly the same version on the production and in your test, because we may end up in the situation that on production there are failures, but tests on the CI/CD are all green, yeah? Let's keep in mind that use the same. And there's extremely rare cases which we encounter, for example, for Kafka, when it comes to the security, production Kafka deployed on the production behave a bit differently than Kafka deployed in test containers. It's extremely rare cases, but be aware that something like this may happen, because still, remember, this is not the real one production system. Last thing, books I recommend. Of course, test-driven development by example, if you would like to get familiar with the basic techniques of the test-driven development. Working effectively with legacy code, not only if you are working with the legacy code, but with the greenfields. And growing object-oriented software guided by test. But be careful with this book. Authors are, if I'm not mistaken, from the Great Britain. And what Great Britain gave us? London School of Mockists. So watch the first part of my presentation and basically skip or take with the grain of salt all advice when they advising you to use the mocks. But it's still pretty good book. Okay, thank you very much for your time and for your attention. Please remember to give the feedback. If you have any question, just approach me after this presentation. Thank you.